Think forward. Think Research Channel.
The pictures and the stones and everything, with time, they fade out.
There's very old pieces of work, and these things like this should be considered invaluable.
We have found a way to preserve and enhance them so that not only Puerto Rican people can enjoy them, everyone in the world can have a chance to experience them.
Technology like this really has the possibility to transform for the patron how they access collections and how they understand their cultural heritage.
An island of striking natural beauty. Its culture and architecture reflect a rich Spanish heritage, accented by a strong Caribbean flair. The picturesque images truly define Puerto Rico. Yet at the heart of that vibrant heritage remains a rhythm, a beat that connects to the time before Spanish colonization, predating the arrival of Columbus. It is the beat of the native people who once inhabited this beautiful island. For centuries, islands throughout the Caribbean were home to Taíno Indian tribes. The Taínos recorded significant elements of their culture with petroglyphs, carvings in granite stone bordering their fields.
A petroglyph in general is a carving on some kind of rock or hard substance. In the case of the Taíno Indians, these petroglyphs were figures, not text, but outlines of birds and animals and other pieces of art carved into hard stone.
The
The petroglyphs express their feelings, what they knew, how they relate with their gods, their traditions, their life in all levels.
The ceremonial park in Utuado, Caguana, was used by the Indians, by the Taíno Indians, to hold a meeting once a year, which was an athletic meeting.
It's been determined by historians that the Taíno Indians used these ceremonial parks for games similar to the Olympic Games, where they would come together to celebrate various aspects of their culture, and they basically did recreation.
In his diary, Columbus noted the tribe's recreation as a sign that they were an advanced civilization. Over time, the sports fields and most of the Taíno culture got buried and became little more than a faded memory.
We began this work together with Professor Herman Acuña, and we worked together to develop a collaboration with the Instituto de Cultura Puertorriqueña, and together we wrote a proposal to the National Science Foundation. And we used the funding to develop computer models of the petroglyphs in Caguana.
In the 20th century, archaeologists rediscovered the Taíno sports fields in Caguana, high in a rugged mountain region of Puerto Rico. The carved rocks bordering the fields were uncovered and organized into a protected ceremonial park. Many have visited this remote place to see firsthand the remains of these intriguing Taíno petroglyphs.
As part of the Museums and Parks program, we have the Indian Ceremonial Park of Caguana in Utuado. Without any doubt, it's one of the most visited places of the Institute. We receive many visits, from students in their field trips up to visitors from Europe and around the world.
The park represents a fascinating archaeological find that is enjoyed by a broad spectrum of visitors. But with each passing year, the effects of erosion on the exposed rocks has become more significant.
This the stones are being spoiled there from the weather. And after a while, we won't have anything left, just a pile of sand.
A preservation company was hired to clean the stones as a first step in what would become a multifaceted archival process, and so began the Petroglyph project.
As part of the preservation process, these rocks were actually cleaned. And as you can see in some of the rocks, some of the dirt was actually left in the carvings, making the carvings themselves very obvious to the casual observer. However, as you can see in other rocks, the carvings are very hard to distinguish from the regular rock surface. And the preservers obviously had a hard time seeing the difference also of where the carving stopped and where this normal rock began.
As the first day arrived, unseasonable rains threatened the project's tight schedule. Although the sun was expected to be the biggest concern, the rain and mud created a new challenge. Washed-out roads were nearly impassable.
The acquisition was really hindered because of the remote location of these the Taino carvings. This is in a remote ceremonial park, and while there was electricity, it was many yards from or hundreds of feet at least from the power source, so extension cords had to be run. It was also out in the open in the rainforest of Puerto Rico, or in the jungle of Puerto Rico. So rain was obviously a big issue, along with mud and various other things in the environment.
We used technology in the field to scan the petroglyphs that was really developed well in the lab, but had some issues when we had to face the weather in the Caribbean. And so we did some re-engineering. One of the things we did is that we built a light tent so that we could put the tent over the particular object we were scanning, and we could block the light, and that gave us a way to control the setting a little bit more. That control was really important in order to get the best possible results. The way we scan these models is that we pass a laser over the surface, and the laser is filmed with a set of cameras. Now, those cameras can see where the stripe is across the surface of any rock, and can, with software, then allow us to figure out exactly what that surface looks like in 3 dimensions.
While the lasers scanned the length of each rock, cameras placed at a variety of angles and distances were calibrated for proper triangulation. They captured and recorded even the slightest variations in the surface of the rock.
The main challenges for this type of project are basically interacting with the surface. Different variables on the surface, such as dirt on the rock, or different flecks of different type of materials that are actually inside the rock, can cause a lot of issues when trying to determine the position of this laser stripe. And that can really throw off the algorithms and add noise to the final calculation. Another problem we have while scanning is, since the surface is not perfectly flat, there'll be areas that can't be observed from a single position of the scanner. So to compensate for that, we'll actually take the scanner and move it and acquire it from another position, so that the entire surface with the important carvings can be digitized.
After each scan, the data was synthesized into an accurate 3-dimensional computer-enhanced replica of the rock. The moving laser not only created an exact image of the visible petroglyphs carved into the surface of each rock, but by measuring the smallest variations within the depth of the rock, the laser revealed images already erased to the naked eye.
The modeling process is very much a staged process, where the lowest level stage is to just obtain very accurate 3-dimensional points that lie exactly on the surface of what we're scanning. That being said, when you put all of those points together and you're able to connect them into a 3D model, those points basically define the model, and so you don't have to sculpt the model yourself. The object itself suggests exactly the shape, and that's exactly what's obtained from the scanning process. So you can think of it as a complete and accurate 3-dimensional replica of what's actually sitting in front of the equipment.
The time it takes to transform the raw data into the complete model, since the geometry is actually calculated automatically, and that time could be upwards of an hour or two, then on top of that, there is a little bit of extra manipulation that we do just to combine different scans. If different portions were hidden from the position of the scanner, then we acquire those different scans and put them together. And that also provides us with a higher resolution model by combining multiple scans.
Normally when you talk about resolution for 3D models, you're really talking about the size of the working volume and the number of points within that working volume that you can capture. So if the overall rock size is a meter squared, then you're talking about the number of dots or samples within that square meter region.
The scanning resolution for the rocks is close to 0.5 millimeter for every point sampled on the surface. Now that varies depending on the size of the object that you're acquiring, but for the rocks themselves, it was around 0.5 millimeter.
The resolution of the scans that we are able to get of these rocks, these petroglyphs, now is in the millions of points. And I mean in millions of points for a very small piece of an entire rock. So you can actually multiply those millions of points into tens of millions of points per every rock. It's just amazing the kind of detail and resolution that we're able to obtain.
Centuries of erosion had worn away portions of the petroglyphs, making them almost completely invisible to the human eye. But even those faded sections can now be enhanced in the computer model and to make them stand out.
We have these models now constructed so that we can see the detail of each of these petroglyphs from anywhere in the world, basically across the internet. So anyone who's interested in seeing some of this culture, some of this artwork, they're able to access that basically from their desktop.
So the purpose of actually digitizing and creating the 3D models is to be able to transfer them. You know, since it's a completely digital form, we can easily send them to different scholars or different people interested in looking at the petroglyphs and researching them. The main complications with networking or providing these models to other users remotely is mainly the size of the data. Since each of the rocks and their full resolution are multiple gigabytes, it's hard, you know, it's not something you can just email.
Once we get things digitized, there's always a component that includes the distribution of that material over, say, a network. The numbers of points of samples in these 3D models are enormous, as I said, millions of points. And so it becomes a very serious network problem to be able to access these things in their highest fidelity across the network. I'm partnering in this project with Dr. Ken Calvert and Dr. Jim Griffioen. And as partners, they both bring expertise to this project that has to do with how to manage this network problem.
This project actually arose out of a previous project on digital libraries where we were addressing the needs of humanities scholars trying to access digital collections. And the goal was to provide them with high-speed access to remote libraries and digitized artifacts. Current technology that's used in the internet to actually transport data from one machine to another, which is what we would use to actually access collections at a digital library, is to actually send data across one path between the two locations. The advantage of our work is that we've actually come up with ways of using multiple paths across the internet to pull data across at much higher speeds so that people can get access to these high-resolution digital collections much more easily.
If you have a warehouse full of stuff and you want to ship it out, you kind of like to be able to send it by train and by plane and by ship and by truck, okay? The internet today sort of limits you to one of those modalities. It says there's one way to get from here to there and all the information is going to go the same way.
Finding multiple paths is actually a complex problem because first of all we have to find out which paths across the internet are available and how much capacity they can handle.
And we do that by building an overlay, by enlisting the help of some other systems. So we're going to deploy some infrastructure that is going to allow us to send the data over different paths from point A to point B. And the reason we want to do that is to get the data there faster.
Our goal is to try to not overload the network with too much traffic. And so what we've been working on is a protocol and an algorithm that tries to find out which are the best paths and then select from those paths across the network. We've developed higher speed protocols that allow greatly improved transmission of data between the user remotely and the actual source of the data the library that it's coming from. And so we can actually enhance performance, and that's obviously seen by the users of the system. The other aspect that I think is very interesting is that we've taken computer science techniques and applied them in a very useful way to real-world problems to help scholars in other areas.
It does provide a way to give remote access to users. And users, since it is a full 3D model, they can rotate the models, they can zoom in, look at different areas of the carvings, and just have ability to give full interaction to the models.
There is nothing that can substitute for an object, a real and original object. But technology can be accessed throughout the world, and for people who don't have the capacity to visit exhibitions or buy books, technology can make many different objects accessible. One of the reasons that the Institute is glad about the deal in collaboration with the University of Kentucky and the University of Puerto Rico is that we are digitizing and developing programs so that we'll be able to take digital objects to different counties of the island, and this will make our collection accessible.
Adeline Rios Rigao, who was the director at the Instituto, was instrumental in giving us the access that we needed to the collections. She partnered with us and worked with us on each visit to make sure that we could have access that we needed.
The mission of the Instituto de Cultura Puertorriqueño, which was founded in 1955, is to preserve and conserve the cultural patrimony of our country. This mission of the Institute needs continuous development to allow Puerto Ricans and visitors to enjoy our heritage and patrimony.
Working with the Instituto was a great opportunity for my research team because they have a vision for the future on how they want to preserve their artifacts and present them to the public. Our technology was a perfect marriage with that vision.
I think that in the case of three-dimensional objects, it is fundamental to use such technology. With planar objects, the only concern is height and width, and regular professional photograph is enough. But with three-dimensional objects, it is important to appreciate the shapes, depths, curves, as well as damages and missing parts of the sculpture. The collection of the Institute is extensive. It consists of about 32,000 objects, most of which are in storage or archives. Therefore, they are not available and almost never have been available for the enjoyment of our people. Over time, some objects had suffered and deteriorated. The most important reason to conserve is to guard and protect the objects to avoid the necessity of restoring them. It is really important to document everything because when you have documents, you can publish. And when you publish, you are ensuring the future generations will have the opportunity to see and learn what we can see and enjoy today.
Ver, aprender lo que hoy nosotros podemos ver y disfrutar. Yo creo que este proyecto de la Universidad de Kentucky.
I think that the project of the University of Kentucky, University of Puerto Rico, and the Institute is very important because we will have a model of how the petroglyphs were and how they are today. This preservation method will guarantee that with the technology and professional methods, we can see the depths, what is happening with the rocks, and how they have been changing over time.
And we really look forward to doing more of that kind of work with institutes who are interested in the future of technology and how that can impact collections like the ones that we find in Utuado and in San Juan. The support for this project at the University of Kentucky was great. We needed that support because we had to assemble a fairly large team of people who were going to do work here on site in Puerto Rico and also in the lab in Kentucky. Herman Acuna has been a great collaborator from the University of Puerto Rico, Rio Piedras. As part of this collaboration, Herman has helped with the local arrangements and the students who've been involved on the University of Puerto Rico side. In fact, we've had graduate students from the University of Puerto Rico come and work with our research team at the University of Kentucky.
We have been doing this for about 5 years now. recruiting students from computer science, from biology and chemistry. And then they go to Lexington for 10 weeks and they do undergraduate research. It has been a marvelous experience for them. Every time they go there, they learn a lot and are very happy about it. It's a new experience, a different experience for them. It's not just taking courses, but a real research experience.
I'm Jesus Caban. I'm from Puerto Rico. I came here 2 years ago to start my PhD in computer science. And I'm working in different projects, and I'm like a developer, creating software and doing research for the projects. Case excited about the research that I'm studying and learning a lot about my area in computer science, that is visualization and computer vision. So applying all the knowledge that I received from my bachelor and my graduate classes, apply that to the research. It's really excited to see the results.
I have to say the students really enjoyed this project. We had a lot of opportunity to travel. It was a lot of hard work, but there were certainly points where they learned a lot of information and helped a great deal with the project.
The project I have specifically worked on has been to digitize some sculptures from Puerto Rico, and that's incredibly important because the sculptures were deteriorating, and we have found a way to preserve and enhance them so that not only Puerto Rican people can enjoy them, everyone in the world can have a chance to experience them.
I do a lot of different things here. Like 1 week I'll be taking out backgrounds of pictures of art, and then next week I'll be making a 3D digital gallery for the art.
Puerto Rico was a wonderful experience. I had never left the country, and it was neat to be able to see how different people lived, and it was neat to be actually on site conducting research. It was a lot of fun.
It has been really nice working with this collaboration with Puerto Rico, because me as a Puerto Rican have learned a lot, and I'm happy and glad how I can help the people in how to preserve part of the culture.
Well, the opportunity to travel to Puerto Rico and to see another country. I've never been out of the country, so all that is really new to me, and just that opportunity, you know, is a big deal.
The main impact the project had on me was just to gain a better understanding of how large of an undertaking these projects actually are. I've seen a few other projects demonstrated in the media, and until you actually are involved directly with one, you don't get an idea of just all the inner workings that are involved, not only the technology, but just the transporting the equipment and, you know, finding a place to stay and driving to the location. Just all these different factors. It really adds to the just my understanding of, you know, any future work, how much planning it really takes.
For me, you know, the most exciting part was to see my team be involved in such an interesting piece of work. I mean, we developed this idea start to finish, deployed it in the lab, traveled there, deployed in the field, made it work, and then came back and did all the post-production, and I think the results are excellent.
Yeah, we were very happy with the outcome of the project. As always, there's things that we wish we could have changed or made a little bit different. It would have been nice to scan all of the rock faces, but due to time constraints and weather issues, that's very difficult. We really feel like we were able to make a contribution by providing this data to users and just preserving it digitally.
I didn't expect some of the challenges, but I was so proud that the team was able to basically make adjustments in the field so that we could get the data that we were looking for. And we spent an enormous amount of time after we got back just looking over the data, making sure it was correct, polishing it. Overall, I would consider it a very huge success. Much of my research has now become connected to work with the antiquities like what you find in the Instituto. And it's become very personally satisfying for me to see projects like this come to a conclusion, where we've recovered models that are very detailed, haven't been constructed before, and then we give access to those models to school children, museum goers, the general citizenry. Being able to be a part of that has been immensely satisfying just personally, and I really think that there's a future for museums all over the country, all over the world, to continue to integrate technology like this into what they offer.
The challenge of digitizing the Taino petroglyphs has paid off. Not only have the stones been scanned, archived, and digitally enhanced, but they are now more accessible. Three-dimensional computer models and spectacular images can be displayed on any computer desktop across the island of Puerto Rico. Through the extensive work and innovative technology developed by the research team from the University of Kentucky and the University of Puerto Rico, the Petroglyph project opens up unprecedented access to the Taino carvings. The Petroglyph project ensures that the connection of the Puerto Rican people to the vibrant rhythm of the Tainos remains rock solid and steady for future generations.
Technology like this really has the possibility to transform for the patron how they access collections and how they understand their cultural heritage. And the people here at the Instituto really understand that, and they're interested in looking for new technologies and integrating them into what they can offer their patrons. It was a great opportunity for us to be able to be a part of that, and we're really looking forward to what the next thing is going to be.